I got the problem 4/6 plus 5/6, and you can see that my student got 9/12. Now, that's incorrect. Their misconception is that they're thinking of the fractions as individual fractions, or individual numbers. They're not thinking of 4/6 as 4/6. They're thinking of it as 4 and 6. So they just added the numerators and denominators together separately. So they got 9/12. Well, the correct answer is right underneath that. It's actually 1.5. So they're probably thinking once they see this answer, how did we get a whole out of these numbers? Well, I would show them they're thinking 4/6 plus 5/6 equals 9/12. Now you can see that our answer is actually going to be a lot larger than 9/12. But I would also show them that 4/6 and 5/6, those answers are, or those fractions are very close to a whole. So our answer is probably going to be larger than a whole. I'd also pull out the whole bar, and I'd show them that our answer is going to be a lot larger than 9/12. Then I would also give some context to these numbers, kind of help them better understand what they did incorrectly. So basically, you're hosting a baking party, you went to the store but you forgot milk, so two of your guests offer to bring whatever they have at home. One guest has 4/6 of their gallon left, the other has 5/6 of their gallon left. So if they both bring that to the party, how much milk will you have total? Now, I'll use the 4/6 to show our first gallon here, and our 5/6 to show our second gallon. So what we want to do is we want to see a total amount of milk that we have now, and that means we're combining these gallons. So let's try to pour the 4/6 gallon into our 5/6 gallon and see if we can fill the 5/6 gallon to get one full gallon. So we'll have a whole bar here representing our full gallon. Now, once we fill our 5/6 gallon and try to fill it with our 4/6, you can see that we're going to spill over. So we actually only needed 1/6 out of that 4/6 gallon to fill this 5/6 gallon. Now, this shows that we actually still have 3/6 left in that 4/6 gallon, and 3/6, isn't that just 1/2? Because we can take 3 and 6 and we can divide those both by 3 and we can get 1/2. So that's how we get our whole and a half. Now, to show them a different way of seeing this, I'd bring out 2 squares to represent 2 gallons, our 2 gallons of milk that our guest brought. Now, the first guest brought, our first guest, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 5, 6, okay, so our first guest brought 4/6 of a gallon. Our second guest brought 5/6 of a gallon. Okay, now this shows that we have 4 bars shaded. Now we want to see what it would look like if this whole square, we want to see what it takes to get this whole square filled. So we can actually just move these 2 over, have these shaded. These 2 will be empty here. So we actually have a half left, 3 bars out of the 6 filled. But also mathematically, we can show 4/6. We really added 2 more bars from the 5/6 gallon. That's what we did to fill this gallon. We added 2/6. So that gave us our whole gallon. Now, what we have left is 3/6 of a gallon, and that reduces to a half. So that's how we get our answer of a whole and a half.